Then I'm just so happy that I lose it. Ohayo gozaimasu. Did it make any sense? Okay, so first of all, good afternoon, everybody. Thanks for coming. Glad to see you, and I'm glad to see many familiar faces. Now, I know that I speak in English with a strange accent, and your translator will translate it to Japanese, and you need to understand what I'm talking about. So I would like to have an eye contact with you. So my request is only one. If you understand what I'm saying, do like this with your head. Can you help me? So I know that I can continue. And if you don't understand what I'm saying, please do like this with your head, so I will feel good. Okay. So, actually I'm going to use the coming hour to share with you how computing technology is evolving across desktop, notebook, netbook, and I'll give you a sneak peek into the tablets today because definitely it's a hot topic, many people are speaking about it. I'll also give you a sneak peek into Sandy Bridge, which is the next generation of the platform that we are going to deliver early next year. And as you'll see, this will be something huge. But first, before I go into the technology, let me share with you one point from presentation I gave to the journalists last year, and some of you have seen it. Last year, we've been bombarded by bad news. Global economic crisis. The world is collapsed. Some people call it the meltdown. It will not be the same world as before. Everywhere that you turn and you spoke, bank or failing, company went bankruptcy, and actually you see panic investors all over. The bad mood of this environment was reflected also in the PC business. If you are trying to see what was the forecast last year, it was pretty scary. In 2009, from initial forecast of 296 million approximately, the forecast went down to 262. The people believe that actually the numbers will go down. See what a difference 1 year can make. When we look today, in 2010, we see that actually not only that it didn't go down, the total available market went up by more than 60 million units. And again, I'm not saying it to give Gartner a hard time. It's Gartner, IDC, and all of us. Intel made the same mistake. Everybody was sure that things will go down. So, if we look at the worldwide economic turbulence, we look at the GDP, gross domestic product, we can see the economic shock. You can see over here what happened to the world, and we all knew it. This is not surprising. But what surprised all of us is this. The PC consumer continued to grow, ignoring the economic shock. People continue to grow it, to buy it. And the question is why? How come that the PC business, or the consumer PC, continued to grow and didn't follow the economic meltdown? By the way, you can help me with this. I'll go faster. Okay. So if you are trying to look, I took a few examples, but this is from the US. And you look at the Consumer Electronic Association, what is the best gift? What people would like to have for holiday? So you see in 2007, second position, it was notebook and laptops. People call it different name. 2008, first position. 2009, first position. And actually, I believe the answer is that we found out that notebooks is not luxury anymore. It's necessity. We are connected to the internet all the time. It's not luxury. You need a house, you need food, you need a car, and you need internet connection. And for that reason, people continue to eat when the economy went down, and people will continue to use notebooks. The other thing that I spoke with you about, last time when I was here, I said this is the prediction. But now we can say this is reality. We spoke about personalization. Personalization. And I believe here a year and a half ago I did this experiment, and I'll try to do it once again. So please cooperate with me. I know it's very difficult during this translation. So I'll ask you questions which are totally not personal. Okay? Okay? I look at that aquarium over there. Okay? Good. Who over here is married? Raise your hand. You don't have to be ashamed. I'm married too. Raise your hand. It's okay. Okay. Second question. Who here is happily married? Raise your hand. Okay, I lost you. Fine. Only of you that are happily married, if your spouse, if your wife will lose or your husband, sorry, will lose the phone, how many of you will give his own phone to his spouse? Raise your hand. Look around. Not only one. You're afraid of your wife, huh? And the reason is that it's not that we do not like our spouse, our wife or husband. This is personal, you do not share. It's my phone number, it's my picture, it's my calendar, it's personal. So I'll buy my wife a new phone, but I will not give her my phone, because it's personal. And then we saw what's happening in the phone industry. From one phone per house, to one phone per room, to one phone per person. And we said that in the PC industry, if indeed you believe that the PC, the notebook, become personalized, we'll see the same phenomena. For one desktop per home, let's say no desktop per room, to two desktops per home, to one notebook per house. And I believe this is the phenomena that we see. And I used to say to people, there was a lot of argument if it's personalized or not. So let me tell you one thing I believe. That if your notebook will be broken, the first thing you do tomorrow morning is go and buy a new notebook. And I believe this is the essence of personalization. So again, I don't know if it can be translated to Japanese, but what I used to say is, well, tablet is a hit. Everybody speaks about tablet. PC is it. We'll have many more PCs. And I will not shy away from tablets, and I'm going to share with you quite a few tablets to see what's happening. But PC is still big industry, and the most important thing, PC will continue to grow in the coming year if we'll be smart enough to design the PC in such a way that people would want it. So the summary that I said is that the PC defies economic turbulence. And we have another test this year, because we'll see what's happening in Greece, and in Spain, and in Portugal, what's happening in Europe. And I will not be surprised next year that although the European economy has got hard time, we'll continue to see the PC going like this, definitely not following the economy. Let me go and repeat, I believe Kaz was touching it, on the compute continuum. We believe the compute is going all the way from server to desktop, laptop, notebook, all the way to phone, TVs, up to embedded devices. We at Intel believe that if we'll be able to design chips and the technologies and the communication between the things, we'll be able to deliver a unified experience. So if you'll have your notebook and you'll have your tablets and you'll go next to each other, they will synchronize, they will share. Every device will have the same architecture, and we'll be able to design it in such a way that the continuum will be one architecture, and you, or the people that develop it, will be able to take advantage of the fact that it's one architecture. But first of all, let me zoom a little bit more into desktop and into laptops. So if you look 5 years ago, and again I need to be very careful, because until 2 years ago, I was responsible for the mobile. Now I'm responsible also for desktop, so I need to speak nicely about desktop as well. So if you look, until 2 years ago, majority of the market was desktop. In 2003, when we introduced Centrino, only 18% of the notebook, everything was desktop. And the desktop, we call it in English BBB. It was big, it was beige, and it was boring. It was ugly. And normally what we did, we put it under the table, so nobody will see it. Today, we design different chips and different solutions. The market is kind of having different segments. If you look at the desktop, it's not the same desktop. It's beautiful desktop for the gamers with all these graphics and all this overclocking and turbo, all the things give you this great experience. The all-in-one, which are very nice, put them on the table. I know that you see many all-in-ones in Japan. You've been one of the countries that have been taking it forward, but definitely looks totally different. And entry-level, cost-effective, we have an Atom. The same thing in the notebook segment. We've got the gaming, we've got the ultra-thin laptop that I'll speak about it definitely because I believe Japan was trailblazing. You've been among the first to adopt it, and netbooks. So it's not the same thing. We've got segmentations with different solutions to different segments. Last year, I was speaking about Calpella. And at this time, I was doing head waving and showing foil. This year, we already have Calpella in the market, and actually we deliver to our promises. I wanted to do demos over here on turbo and other things, but everybody told me, hey, you do not need to teach in Japan about turbo. The press is fully aware of the turbo. The people are aware of the turbo, and actually you don't need to do the demo. Well, once in my life, I didn't argue. I accepted it. So let me just do a quick recap. Calpella, we have many, many features, but 3 features have been the highlight. And for the little Japanese that I understood, I believe Kazu covered it as well. One is the turbo boost technology, which we are so proud of. The second one is the hyper-threading. We've got 4 cores, up to 4 cores. Each core has got 2 threads. Altogether, you can run 8 threads in parallel. And we've got the Intel high-definition graphic, which has great graphic experience, but also media experience. And this is very important to understand. Because we in Intel put more and more focus on the media. And I'll tell you why I believe it's so important. Who here believe that if you've got graphic and media, who think that graphic is more important than media? Raise your hand. Graphic more important, I look at you. Who think graphic is more important than media? Nobody's willing to take the risk. Who think that media is more important than graphics? At least one brave lady. Let me ask you a simple question that you don't need to take position. Who played high definition, I'm taking a risk. Who played high definition 3D gaming today? Raise your hand. Today? Okay. Who played high definition 3D games in the last 3 days? Raise your hand. High definition 3D. Look around you. These are the people who do not work too hard, but fine. This is 3D gaming, graphics. Who watched YouTube in the last 2-3 days? Raise your hand. Look around you. This is the difference between media and graphics. So again, don't misunderstand me. Graphic is important. We deliver a lot of experience. But probably media, in the way that we consume media, is just as important, probably even more so. With respect to the turbo, let me just do a quick snippet. This is the performance meter that we can have on the computer. Alternate control delete, performance, remember? Alternate control delete, performance, you can see. And you see that when we look at the performance on the average, the performance that we take for a computer is pretty steady, but every here and there, we've got a spike, and we developed the turbo in order to be able to deliver this performance whenever you need the spike. So you'll have a great responsiveness. And this is what we did in order to do it. So people ask me, who need it? Who needs all this performance? And my answer was, it's you, it's me, it's us. and I believe we've got a demo outside, but you can look what's happening with the turbo when you open email, or PowerPoint, or pictures, or Picasa, or whatever you do, you can see this turbo is going up and down, delivering this great performance. But if we try to show you the animation, and I believe you've seen it, this is 4 cores, and we can turbo even the 4 cores, because if the core is not using all the assets, all the circuits inside, it can turbo a little bit. If we work with only 2 cores, we take all the power which is not used, give it to the 2 cores that are working, increasing the voltage and the frequency, and as a result, we get boost. And if we've got only single core, we can take all the power, give it to 1 core, and the core can go much higher frequency, and as a result, give us much better responsiveness. Are you with me? Yes, no? Help me. Guys, are you with me? Yes or no? Yes. Because from now on, it's just going to get more complicated. But you love it. So we say the following. If you Israeli explained with the hands. I need both hands to explain. So, if you look at the turbo, the idea was we take power from 1 core, it's not using, we give it to the other core, right? Now, if we've got 2 chips in the same packet, the graphic and the CPU, actually we can use the same idea of turbo between the graphic and the CPU. Because when the CPU is not working, I can take all the power from the CPU, give it to the graphics, and run the graphic much faster. If the graphic is not working, I can take the power from the graphics, give it to the CPU, and now the CPU will turbo and run much faster. Does it make sense? Yes, no? Okay, so let's look at it, and what I did in order to explain it is the following. This is the way that the chip is looking. You'll be able to look later on, I don't know, I probably lost it already, I don't know where I have it, but I have this, you have it? Yeah. I'll be able to show you the chip. It's 2 chips. On the left, you've got the CPU. On the right hand, you've got graphic. The CPU is smaller because it's 32 nanometer. The graphic is on 45 nanometer. But what's important, I told you, we can share the power. In order to show it to you, we took an infrared picture of the chip. When the CPU is working, then suddenly the graphic is working. And in most of the applications, they do not work together. So look at it and see how the heat is moving from one to the other. Here you can see the CPU is working. Now the graphic is taking command and gets all the power from the graphic. CPU, graphic, both of them. This is the way that we do turbo, not only between the core inside the CPU, but between the CPU and the graphic. And this gives us many percentage of improvement on the graphics of Campena. You still with me? You're really helping me, you know, I look at you all the time. All the time do like this. I just hope you understand what I'm saying, otherwise. Okay, thanks. I mean, you can't mention it as well, guys. We've got 1.8 billion users of the internet. Huge increase over the last few years. Web pages, 1 trillion web pages. Try to imagine 1 trillion web pages. Social networking. Guys, the social networking is not a computing revolution. It's a social revolution. We behave different. We think different. Not so much we, but definitely the younger generation. 500 million people on Facebook. In China, 46 million on Send. In Japan, 20 million on Mixing. In Orkut, Brazil, 52 million. Most of the time that people spend on social networking, in which country is it? Brazil. Second, Turkey. US, number 9. So people really use a lot of time on the internet. If you look at YouTube, I didn't believe this number. I asked my assistant to look at it again and again. 2 billion downloads every day. 2 billion every day. Can you imagine the number? And if I look at it, pictures. People post 3 billion pictures per month on Facebook. This looks like Japanese for me. I'm here. 3 billion pictures per month on Facebook. 2.8 billion pictures per month in PRC. Latin America, the number is amazing. And the interesting thing is that if you look at it, YouTube is only 20% of the traffic on the US. Why do I repeat all these things and tell you? Because we need the compute power to handle it. A picture used to be 1-2 megapixel. Today it's already 10 megapixel. Video, we used to do standard video, standard definition. You push the boundary. Definitely Japan was the front wave of this revolution. Today you use high definition. High definition has 6x time the amount of data that you need to digest, you need to work on, you need to edit, you need to transcode and put it on the internet. This is the data that we are using. Why do we need? Because if there's so much video using, you can compare the i5 to Core Duo, which is a 3-year-old system. And again, I say, definitely Japan was leading it because you adopted it much faster than anybody else. If you try to do photo editing, Picasso, whatever you do, you can get 2.1 times faster. If you are trying to do video conversion, it's more than 3.2. And guys, video conversion sounds like something that a technical person is doing? No. When you connect your camera, I was in a vacation 2 months in Vietnam. And I bought myself a high definition camera, it was a Sony camera. And every day when I came back, I just connected my camera to my PC. You know what I did? My wife didn't know it. If she knew, she wouldn't ever do it. I did transcoding. I took the picture from the Sony, which was encoded, I decoded it, I changed the format, and I encoded it back to my PC. But a normal person doesn't know that he's doing transcoding. You just connect the camera to the PC. But that's when we need the performance, because I was waiting 15 minutes. Here, I could have waited 5 minutes. And we'll go to Sandy Bridge. Oh, this is going to be so fast. I'm not telling you the number. I want you to come to the US to IDF. So, I'll come to it in a moment. Ultra-thin laptops. Definitely, I believe that if we look at the definition, if we look at the revolution, in 1980, we've got the Lagrange area. You know, it was a big, it was a compact. Actually, it was without battery. You need to put it into the electricity, but we've got this Lagrange, like a suitcase. And then we start having revolution. And the revolution went out one after the other. In the late 80s, we've got the rechargeable batteries. Hey, it starts resembling laptop. In 1990, I believe actually it was 1996, we started having the color LCD. No, sorry, the color LCDs, and it started getting much better picture. In the 2000s, we start having much more wireless and mobility area. Many of you are start meeting you since 2003 when we introduced Centrino. And then we've got the multi-core era. We can do many things in parallel, real multitasking. We started with Visiona, with Core Duo, Core to Duo, and now we continue. And now we're in the ultra-thin area and the WiMAX. I will not expand about the WiMAX because I believe Kaz, from the little Japanese I understand, I believe he expects the importance of broadband. But definitely, this will be more and more. We need to build the connectivity all the time, always on, always connected. And when people carry it with them all the time, they want to have it very, very light. So I've got several systems over here that are using our ULB technology. I've got an NEC system over here. And again, later on, I believe you know many of the systems. You'll be able to come and take the picture. You'll have a Toshiba system. You've got a Fujitsu system. And over here, definitely, I've got another system. I've got the Panasonic system, which is very interesting. Not only that it's got the WiMAX, also it is using the ULB technology in order to reduce the overall weight of the system. And I believe definitely that Japan is kind of leading the charge in utilizing the ULB and coming with very nice systems. And I'll come to it back in a second. So this is the ultra thin. We put an example, and again, we can see many, many systems going around. Why is it so important for us? And why are we so proud? Because if you look at the turbo technology, the thinner you are, and the more constrained you are in the power, the more you can get out of the turbo. So if we are looking at the ultra thin that was introduced here lately, On a multitasking environment, we can get up to 35% faster. If we are trying to do video editing, 40% faster. If we are trying to do graphics, more than 2x faster. So I know that in the beginning, some of the people claim that in the ultra thin, they would like to have more performance. We are delivering this more performance. And in Capella, you see a step function in the performance, mainly utilizing the turbo feature in order to be able to deliver. Guys in the aquarium, are you still alive? Good, I'll continue. Okay, let me give you a sneak peek into Sandy Bridge. Sandy Bridge is going to be the new chip that we are going to introduce early next week, early next year. Wow. Early next year, I don't want to mistake in the press. Early next year, and the platform is going to be Huron River. Actually, I wanted to show you the numbers, and I'm sure that the guys will ask me about the architecture and how wide the machine is, and what's the frequency, and how the branch prediction is working, and what is the cache, and is it a shared cache? I will not tell you. Because my competition want to know it as well. But as we get closer and closer, we'll share with you the architecture, and I believe you'll be proud of it. It's really brilliant chip. It will be incredible smart performance, and if you believe that what you see here in Turbo is the max, you'll be surprised when you see Sandy Bridge. There'll be Super Turbo, whatever the name will be, but actually you'll be able to turbo it even more than what we are turboing today. So you'll see that if you need the performance, you'll get it in mark immediately. When you look at the media, it's going to be stunning media. You'll just be drooling when you look at it. It will be unbelievable media. Both the quality and the performance, when you need to do transcoding or decoding or encoding, you'll see totally different. And I know, again, I see some faces that I know for the last 7 years. Mooly, how do you do it? Is it hardware? Is it software? Is it the CPU? We'll share it, but at the later stage. The graphic is definitely going to be totally different. You look at the graphic, and I would say, I'll take the risk of saying that probably all the casual graphic that you are looking at, you'll be able to do it by the integrated graphic of Sandy Bridge. And I didn't have enough time over here, but what I did, I put a Sandy Bridge system with integrated graphic next to a painter with a very strong discrete graphic, and I was playing games, Warcraft, the World of Warcraft, and all this kind of thing. You will not be able to tell me which is discrete and which is integrated. Again, don't misunderstand me. If you are high-end gamer and you want to play top of the line, the most fastest game that has been just released, maybe you need discrete graphic, 100Y, SLI or ATI/AMD. You need the top of the line. But the casual gamers, our integrated graphic will be more than enough. Battery life will be great. Will be better than Capella. And for you guys in the first row and the second row, Sandy Bridge will have 1.16 billion transistors. Try to imagine it. 1.16 billion transistors. And if one of them is not working, the chip is not working. Ain't it amazing? By the way, I can simulate and see that it's working. I cannot understand how deep inside it doesn't make sense. It's too complicated. Engineering-wise, I understand how to do it. Feeling, it seems to be very good. It's unbelievable. 1.16 billion transistors that are going to be in every house, in your notebook or in your desktop. That's what you're going to have. What are we going to have? Let me give you an example of what's happening here.
This is the hottest of the season. Okay. No. It's a little too busy, too purple, too short, too hot. Yeah, that's new. Okay. I think my mom wore this. This is great. Look.
What does this have to do with my presentation, besides the fact that it's a nice video? This looks almost like casual, need to come usage model. This is courtesy of Cisco, this video thing. It looks pretty simple. It's not, guys. If you want to choose a dress on the internet, you want to have an avatar of your body, and you want to pick a dress, put it on your body, and see how the dress is falling on your body. How the dress looks on your body. Is it too tight? Is it too short? Is it too long? Like in my case, normally it's too long. Thank you. This was supposed to be a joke. I will not try it again. I will not try again. Promise. Okay. If you need to calculate it, you need a lot of compute power. Until recently, you need a server to do this computational. It's not simple to calculate how the dress will flow on your body. At Sandy Bridge time frame, you'll have enough compute power to do it. But I know that in Japan, many of you are kind of gaming geeks. You like games. Let me show you how the games are going to look pretty soon. And again, I'll come back and connect it to Sandy Bridge later on. So let's take a look at it.
Right, rolling my eyes. You should be able to see me do basic mouth movements like when I'm talking. And you should be able to make me, see me be happy, or sad, or surprised. Those are my basic movements.
I'm sorry I failed you, my lord. I submit to your punishments.
This is when I need to stop and you need to say, wow! But I will not get it in Japan, I know. It's too much. Okay. What you see over here, you can say, well, it's not a big deal. We have seen it. Where did we see it lately? In which movie? Avatar, right? But Avatar used a form of server to create it. Try to imagine that I'll put the camera on my Sandy Bridge, will take my picture, and I'll be able to do it real time. Either in the game, or if I'm sitting drinking in my house beer with my friend, and my wife called me, instead of having my picture, I put the avatar highlight. I'm working very hard. And you can see the avatar instead of you. We believe that this will change the way that we are working. We believe it will blur the border between the real world and the virtual world. Pretty soon, I believe we will not know what is virtual and what's real. And especially in the gaming world, I believe we'll be able to deliver experience that you have never seen before. So definitely stay tuned for next year. Sorry? Yeah, it's definitely, it's courtesy of Image Matrix that let me use this and share with you. So if I look at the Sandy Bridge, it's a breakthrough architecture, and again I say for the technical people of you, I'm sure that either you'll hear it in IBM or we'll send some of the architect to share with you. I know that we have many technical people over here. It's advanced 32 high-K metal gate technology. It's monolithic, so it's one chip, not like today Tampere 2 chip. It's one chip that will be grabbing the media and the CPU working together, and it's a very tight resource sharing between all of them in order to deliver this performance. Let me go on back to the compute continuum, to the compute continuum, and let me focus on another segment. The netbook, the tablets, and the handheld. That's another segment. Let me start, and again, I would like to make sure to dispel the confusion. People see Atom and think that Atom is one chip. Atom is a family of chips. There are different atoms, different solutions for different segments of the market. If you want handheld, very, very low power. Was just introduced lately, Moorstar. If you want netbooks, you can have more power, but you want more performance. Different devices need different solutions, and all of them are shared by the Atom architecture, but it's not the same chip. If you look at the, first of all, the handheld, Moorstar was just introduced 2 weeks ago. I believe you've seen it. Really amazing power. We've been able to successfully to take it down. And our mobile share with us reference design that you'll be able to see it over here. Google operating system, Android, you'll see it over there in the demo, but this is what you can achieve when you use Mooly. It's a reference design. You can see the thickness, you can see the device. Definitely we believe that with Intel architecture, we will be able to go into the phone space and you'll be able to enjoy all the ecosystem that you have today on Intel architecture. So this is a phone based on Mooly. Let's take to the next level. Netbooks. We spoke so much about the netbooks, and definitely you've seen it in Japan. I believe that even one of the telco sold netbook for 1 yen if you subscribe for 2 years. So definitely you're familiar with the architecture. We believe that we see evolution of the netbooks. 2 years ago, 2.5 years ago, it was the EEPC. Remember? What? Clamshell, you open it, keyboard, screen, and this is what started the category. The main thing about this category was that it opened a new price point. It was very affordable. Today, I believe it's changing, and in the future it will change even more. So let me start with today. Today, I believe we see more and more people start going vertical. Not only the simple netbook that is serving everybody, but specific segments. Women, fashion, style, kids, it's kind of more segment, more vertical segment. Let me show you one example that I hope you like. Okay, what's special about it? Guys, a netbook is not a compute device anymore. It's a fashion statement. People are changing the color of the netbook based on their dress. This is a vertical solution for women. There's vertical solution for other segments. No, I don't even need to laugh. People start doing. This is definitely segmentation. People start looking at it. Don't take any picture. This is not my color. But if you look at it, this is a fashion statement. And the way that Sony promotes it, somebody, I cannot compete with the model. That's too much for me. But definitely, that's a fashion statement. If it was not fashion statement, it was not pink and blue and red and black. It's not a simple netbook. It's much more than that. And I believe we see it more and more as we move forward. Classmate PC. It's amazing. If you see kids working with it, they love it. Why do they love it? And this will take you to the next generation. They love the Classmate PC not because of the keyboard and the screen. The keyboard and the screen means nothing. They love it because of the content. We deliver something that they want. And the reason it's so important for me to speak about the content is because if I go to the future, I believe definitely that we've got huge opportunity to continue to grow the netbook if we, the ecosystem, the software, everybody will be smart enough. Because if you look at smartphones, and again, excuse me, I'm not familiar with Japanese pricing, but I'm familiar with the US pricing. If you've got a smartphone that costs $300, you know how many times people replace it? How often? Every year? Every 2 years? Yes. Every year and a half, 2 years, people replace it. Every 4 years. You are not paying very much, you're paying low. But definitely, people change the smartphone much faster. Why? Not because they need to, because they want to. Guys, it's a consumer thinking. I still find it difficult because I still would like to see myself as an engineer. But if you look at the consumer, this is the way that you do it. And the reason I say it, because when we look at the future, we've got several things that we are going to do. We are going to change the form factor to make it much thinner, much nicer, so you look at it and you say, I want it. And I'll ask you why, and the answer will be, because I like it. You will not tell me about the compute power or all the things we put inside to make it happen. We just like it, it's beautiful. We are going to make sure that we put the right content, the application store from Intel. So the women that would like to have fashion will have a fashion, and the men that would like to have football will have football, and the kids that like cartoon will have cartoon. We need to deliver the content. Because today netbooks, especially in Japan, and I don't know if it can be translated, I say it slowly, it's not an issue of affordability, it's an issue of desirability. People can afford it, the question is, can we make it smart enough that you would like it? So let me give you just one example, you know we cannot do without example. Do you know this? Remember the promotion? So let me show you one, definitely I got my choice. Oh. This is the way it's actually fully functional. It's Pi 12 dual core, you'll see it in a moment. And you see this is how the netbook should look. If you look at the thickness, you can look at me. I don't have big fingers, right? Still at my fingers. So and I'll let you touch it later on. I don't have to charge it before we play with it. But this is the way that I believe if we'll be able to deliver such netbooks, definitely people will desire it. Now, you know that we are trying also to be innovative, so definitely the reason I show you this envelope is just to tell you that we can have two in the envelope. So you see the thickness, I'll leave it over here, people that would like to look at it, but definitely I believe this is one of the things that you'll see that as we move forward, we'll see more and more of them. Okay, so as I say, the challenge of us, the ecosystem, the software, Intel, press, you can help me. Because if you write about it and you will explain it, people will understand that there's a lot of things we can do together in order to continue and grow this category, and I believe the opportunity is huge. Let me move to the next topic, dual core Atom. If you remember, in the netbook, we put only single core. And many people blame me for being the bad guys. Why don't you put dual core? And I read all these terrible stories about Intel do not want to put dual core inside. Guys, two things. First of all, we believe that at the entry level, the affordable single atom was good. What we found out is actually the application, the software is getting more demanding. And we decided to move everything up. So people ask me, is there still a difference? Huge. Because Calpera is moving up, Sandy Bridge will move even higher, but we want also to move the lower end higher because people expect more. People want to have a little bit more multitasking. Because we are human, we do not only one thing, you do two things. You watch the screen, you look at me, and you listen to the translation. 3 tasks at the same time. We would like to deliver it. Why couldn't we deliver it earlier? Because if you've got 2 cores, you need to make sure that the power management is such that you can manage it to save battery life. Guys, the initial solution that we introduced to the desktop didn't have the power management option, and there was no way to put it into a netbook because it will kill your battery life after a few hours. Now we came with the Atom dual core, with the Pi 12 dual core, and I believe you'll see it pretty soon on the shelf, and you'll be able to get even better experience because, as I said, everything is moving up. But I will not be able to finish my presentation without speaking about the new kid in the block, tablets. Everybody speaks about tablets. Those of you who have been in Computex, tablets all over. There aren't many tablets, but people like to speak about it. So this was definitely big thing. I didn't hide it. Intel didn't hide it. We are going to participate in the tablet form factor. Actually, you'll see in a moment. We are going to design special chips for the tablet form factor. So we believe definitely we are going to do it. Why do we believe that Intel-based tablets are going to be relevant? Because we believe that even in tablet, you want to get performance. Performance is still relevant. You don't want to have single-task tablet. You want to have multitask tablet. You want to be able to do several things in parallel. We believe that people would like to have OS mode of choice. Is it going to be Windows? Is it going to be Android? Is it going to be Chrome? Is it going to be Migo? My answer, you choose. That's what I mean, pot of choice. And I believe pretty soon you'll see one tablet with different operating systems for different market segments. Software ecosystem. The same thing that you know for many years. You'll be able to put any software that you want to deliver into it, and definitely rich internet support. Is it going to be HTML? Is it going to be another format? Guys, we do not take side. We try to support all the things, Flash, HTML, you name it, we are going to do it. But you know what, rather than speak about it, we did experiments in Intel, and I know that there have been some things. You'll see 3 weeks ago I showed you the analyst meeting. So this is a tablet, and this is really thin. The only reason I asked you not to take picture is because if you take picture of this with me, I look very fat. So take picture like this if you look better. So you can have here an example, but to show it to you, you'll be able to look at the size. It's amazing. And rather than doing it, why would I invite Diane? Why don't you show some of the things over here? Because we both quite a few.
Sure. We have some very cool tablets here.
Okay. So why would you put it? Again, it's just for the quality. You'll be able to see it, but it's going from here through the project. So we are losing some of the quality, but definitely you'll be able to take pictures, see it later on. What we have over here is a tablet running the traditional Windows that we all know, right? So you can do email, you can do PowerPoint, you can do Excel, but when you're on the go, you want to have something faster. Now the reason I'm showing it, this is the one with the circles there. This is the reason I was surprised, I was last week in Computex. This was not part of the demo. This is the beautiful thing about pot of choice. And one day before I was on stage, somebody came to me and said, Mooly, why would you look at my tablet? And I said, holy, where is it from? He said, I developed it. And I got a tablet I didn't know even that existed. And I said, give it to me, I'll give it back to you, probably. And let me show you it. So when we are on the go, we do not want to work Windows, it's too heavy. So they designed a wrapper, right?
Yes.
Why would you show it to us?
Okay. This is called XOPC. And as Mooly said, it's a wrapper for Windows for those times when you want more of a different sort of tablet experience. So using this interface, I can do all kinds of things. For example, access my books. You can see how easy it is to go back and forth. My music. Actually, there's some educational content on here. If you're going to, learn a little bit about Mars, for example. And you can see also how easy it is to close the application. Just a quick swipe.
And can you go back to Windows?
I actually can. One quick touch and I'm back at Windows.
So this is a wrapper around Windows. What do I want to tell you? Pot of choice. These guys wanted to do it with Windows. And he developed it and he showed it to us. This is the experience. Do we have another one?
Okay, let's see what else do we have here. All right, how about this one?
Many of you heard about Migo, right? The operating system and the user interface that Intel is developing. Let's take a sneak peek. This went through a very strong travel through Computex and everything. I hope that the system is stable because it really suffered lately.
It's been very popular.
Okay,
Getting our hands
so
on
this is the standard Migo interface.
Correct.
And again, either you can choose application from the interface you see it, or
Migo has a very cool interface here they call the panel view. And what this is, it's sort of a one-stop shop for all your digital life. For example, it keeps track of all the websites you've been visiting recently. It keeps track of your social networking, all your friends, whether it's Facebook or Twitter, it's all here in one location. You can see the different videos or the photos that you've been looking at. And it's all here in this one nice, easy-to-use panel interface. Makes it very straightforward, very nice for the
so again, for those of you who took pictures, again, I don't want to do it, but I'll ask Diane to stay over here. She'll let you take, you'll be my model, okay?
I'll stand right here. I'm a little shy.
And she will show you, and you'll be able to take a picture, because definitely when it's going through the projector, the quality is deteriorating, but when you look at it, you love it. It looks beautiful. I believe we've got another example.
I do
that
actually.
we developed, and this is a system I like it. I like to play with this.
Hey, mine's mine.
It's you. Can I do only one touch? I want to look at the videos, and I look at the trailers, and I want to show the trailer. Just a minute. Yes. And this is my favorite. Do you like it? And again, you should see it here. But you can see, we can play. What was your preference?
Yeah, this wasn't actually the video I was going to pick. I have a better video. And I think you'll like this one too, actually.
This is a video, I believe, that 3 weeks ago I was presenting to analyst meeting, but I told them, guys, we are going to be in tablets, but I'm not going to tell you anything until Computex. So they showed it to me, and that's what I thought.
Basically, a lot of big players made a lot of noise about changing their game to get out in front of the product that a lot of folks say doesn't have any game, the iPad. For example, Intel's Mooly Eden hit the stage, looking a lot like the long-lost brother of Steve Jobs. They say his company is now serious.
Let's go on. So this was a cheap shot at me 3 weeks ago in the press conference because I held the tablets and I said, guys, we are going to be in tablets. And you're going to say more. And I say, wait for Computex. So I believe in Computex we shared a lot. You'll be able to look at the tablets later on. But definitely, I'll urge you, you'll see the form factor. And again, the message here is it's part of choice. You choose whatever you want to do on this. I believe you'll be able to do it. And definitely, we are going to develop Migo to a great user experience. And I urge you to look at it later on. Introduction. Guys, next year I'll be here in Japan and you'll judge me. But I'm telling you that we are designing a new chipset or chip complex for the tablet. This will be mainly for tablets and fanless netbooks. Fanless netbooks and tablets. Again, the name is Octrail. Very low power, very low TDP, thermal design point. So you'll be able to do it thin, you'll be able to have long battery life, and I believe you'll see many tablets using the Octrail with HDMI and 1080p and all the things that people are looking into. So, if I look at the opportunity in front of us, I believe that if we do smart things, we can expand the netbook market, and at the same time, the tablets open additional opportunities. 10 million, 20 million, we need to wait and see how much it grows, but definitely it's a very interesting opportunity. To summarize, the PC market segment is strong, and we have significant growth opportunity in front of us. Many times people kind of irritate me by saying we've got the PC market and we've got growth opportunities. No. The PC market will grow. On top of it, we've got growth opportunities. We've got the tablet, we've got the gadget, we've got all the things that you see in Akihabara. We've got many things. But the PC itself is still a growing market. Don't give up on it too fast. The Helen Calpera that we introduced with the hyper-threading and turbo and the high-definition media graphics definitely set a new bar. In Japan, you are the last one to be educated about it, because when I look at the ramp of the i5 and how many you see in the shops, definitely you did a great job and you know to appreciate the value. Sandy Bridge is not going to be an evolution. Sandy Bridge is going to be a revolution. And again, I cannot share a number right now, but I've got many people, we are going together for the last 7 years in 2003. Trust me, you will be surprised when you see the Sandy Bridge. I see the skeptical guy faces, by the way, this is normally the stage that we go outside and we bet about a very expensive bottle of sake. So if you want to take the bet, I'll take you outside. But it's going to be definitely a revolutionized platform. We are very proud of it. And the netbook segment has been established and it's expanding the TAM. Now, if you've got 1 more minute, and I know it was not on the agenda, I don't know if I can challenge the crew over there. Are you with me, guys? Diane, can you come over here? Let me share with you only one thing. Can we take the risk here? Yes? Is it okay or it's crazy?
I guess so.
Okay. Can you stream the Sandy Bridge over to the screen, guys? I know it's not in the script or anything, but I simply like it. Can we? Yes. Okay. So let me just give you an example. By the way, you'll be able to see, please, not too many pictures. This system is Sandy Bridge system. This is the Sandy Bridge system. It's, by the way, it's a form factor validation, so it's not the commercial. It's the one that we designed to see that the thermal, everything is okay. The other one is top of the line i7, right?
Yes.
Which is the best quad-core hybrid threading. Let's take the best compiler that you have today compared to Sandy Bridge and just look at one benchmark, which is the Cinebench, right? Okay, so you can see this is one benchmark that we use everybody together. Just see what's happening when you run Sandy Bridge compared to the fastest quad-core that exists in the market. And you'll see when one is finishing. By the way, very nice to see that when it's finished, it's open again the threads and divide it. This is even before we finished all the tuning of Sandy Bridge. You can see the difference between Sandy Bridge and the fastest available quad-core today in the market. So you can imagine what Sandy Bridge is going to deliver, and then the reason when I showed you the dress that is fitting on your body, all this great 3D, all these avatars, I say, guys, Sandy Bridge will be able to deliver it. And I can go on and on, but it will take time, so definitely don't say one bad word about the current quad-core. This is the stronger microprocessor in the universe today for notebooks, but Sandy Bridge is going to be even much better. Thank you very much, ladies and gentlemen.